You literally put your sample in it and go boop, bap, boop, beep, and then it gives you the information.
And that's why it's been broken for the past 2 weeks.
Yeah.
You're listening to The Cosmic Cast.
Welcome to another episode of The Cosmic Cast. And you're right, everyone. You should be excited. It's season 2.
Woo!
Don't worry, we're back, and we're back for a while now at least, probably until the next holiday that we have, or when we realise we have nothing worthwhile to say. And yep, we haven't already come up with that decision, so let's carry on. You're here with me, Rick Bibber here. To my left, we have Marissa Lowe.
Hi.
We have Tom Harvey.
Hello.
We have Dr. John Pernett Fisher.
Well, hello there.
And it's a great day to be back.
Indeed, we hope that you've all had a lovely summer, and we're very excited to be coming to you in your ear holes right now.
Yeah, coming in.
I'm not sure I like that, John.
Through the speakers, directly into your ear holes.
Yeah.
Today we're going to just basically give you an update on what we've all been up to while we've been away. Marissa's been on a cool trip. They've both, Tom and Marissa, are now in their second year of their PhD.
Yep.
Yeah.
So they'll fill you in, as Craig David says. I think he said that 12 years ago, into what they've been doing. And John's probably been mooching around as well. So,
Yeah, something like that.
Yeah.
And I guess like a sort of a public service announcement, we're all over the summer. Some of you may have noticed we're now also on Spotify and iTunes and various other podcast services. So you don't have to listen to us through YouTube anymore.
So you guys, how does it feel to be in your second year of your PhD?
Very strange. I think I've been saying this to you, Tom. I feel like we started last week, but I also feel like I've been doing my PhD forever.
Yeah.
Like I can't remember what I was doing before this. I assume I was doing something, but I feel like I've been doing this for a long time.
Yeah.
It's funny because on the one hand, I think about how much stuff I've done in the last year, and it feels like loads. But also it's very easy to feel like I haven't done anything at all. But yeah, no, it's exciting. There's much more of a plan in place now.
As you would hope.
As you would hope at the end of the first year.
Less of a plan
than there was when I applied, which was weird. But yeah, so we've done our transfer reports and transfer interviews, which is sort of like a checkpoint to make sure that, you know, you've read enough, you've learned enough, and your plan for the rest of theoretical plan for the rest of the PhD is in place and suitable as well.
So what did it involve? You basically an interview scenario, right? With
Yeah. So for both of us, one of our supervisors sat in with us, and then we had someone internal to the department who asked us questions about our literature review and our plan, and then also just general questions as well.
It's quite a cool exercise though, because at no point prior to that have I ever been asked to plan years in advance. And that's basically what we have to do is you have, I mean, at this stage we have 2.5 years left, which already sounds
crazy.
like not enough time. And we have to chunk that out into kind of fragments of work that we think are achievable. But it's more than just, you know, sticking things in a time chart. You also have to think about what might go wrong, why it might go wrong, and how that would, you know, have an effect on your project if that happens. And then, you know, paper writing, conference attending, all that sort of thing.
Yeah,
the
or
big kind of scary
internships.
stuff. If
you need to pause your PhD for a little period of time to do an internship somewhere, think about how that affects the rest of your project.
Yeah. I imagine for you, John, that was a long time ago, your first year Viva. Is there anything you ever reflect on?
No.
Yeah.
So Royal Holloway didn't do that.
Oh, okay.
So we had no
the process is
first
different
year.
everywhere,
Yeah, I've
isn't
heard
it?
they just handed out PhDs.
Yeah, pretty much.
Yeah,
So no, we had to do one in second year to upgrade you from an MPhil to a PhD program.
Oh, wow. Okay.
okay.
So that's almost scarier because you're originally just on an MPhil.
Well,
not
I think
to degrade what an MPhil is.
That was a much more common route at the time though, wasn't it?
I don't know. Well, not that many people do MPhils still. So no, you start off on a PhD program, but then it's after the second year where they decide you are capable of finishing, or whether they say, well, look, have you just considered downgrading to an MPhil, basically?
But that's a lot of time to put in then if you're 2 years in.
Yeah.
Well, 2 years is how long an MPhil takes anyway. So
Oh,
I
I
think
thought
at the
they
end
were
of
only
that
the
amount
1
of
year.
time, you just wrap that up, write it up, and then.
Mm-hmm.
Well, I think here it's the other way around. You do a year, then they interview you to see whether do you want to just carry on and do an MPhil, or
Yeah.
you're fine. Let's carry
No,
on.
I
with
mean,
the
but I
PhD.
think doing a first-year checkpoint type thing is a good idea because I mean, certainly, some supervisors don't really pay attention, and so it'd be very easy to go through and coast through a first year and not really get anything done. But
Yeah,
I think that's another good observation, though. Is the point of it's not just for the applicant; it's also for the supervisor to check they've been doing their job correctly, making sure they're adequately involved as well, and they know what's going on.
Yeah. For me, it was quite a good confidence boost actually to be like, oh, I am actually capable of doing this. I've just sat with 2 academics and explained what my project's about, answered all their questions on the spot, and they've gone, yeah, you can do this. So yeah, helpful checkpoint and good confidence boost.
And I guess at the end of it, you've got a literature review you can broadly use in your final thesis too.
Yeah, I mean, I've already been looking back at that because it got quite long. It was a big literature review. I can't hold all that in my head, so I've been looking back through it already.
Well, it's a good point because obviously I handed in a few months ago.
Yeah.
Oh, for all the listeners,
Still
I finally
not
got a Viva
validated.
date. Yeah, the 13th of November. So, and I handed in on the 30th of June. So,
how do you feel about that? You must be jonesing to get on in Viva.
it's kind of a weird one because I've already started my postdoc. There was almost no transition between finishing my PhD and starting the postdoc. So it kind of felt like, oh, well, it's already done. But obviously that isn't the case. I really need to do the Viva. So part of me is like, do I remember everything I did during my PhD? I don't know, but I guess it's given me time at least to go, okay, I know it's on the 13th of November. I've got ages to look through everything again and make sure I
Be as
know
prepared as
everything
possible.
can. Yeah.
So Ricci, how is the postdoc going?
Yeah, it's great. It's so just for the listeners, I was a Martian scientist who studied fluvial systems on Mars.
He's not from Mars. He studies Mars.
Yeah, no, I am
Although
from
that would be
Mars.
cool.
Yeah, it's in situ analysis of Mars is what I do. And now I'm doing something completely different because I wanted to get new skill sets that would basically mean I could do anything, which is obviously not the case, but it would open me up to other experiences. And so now I'm looking at dust particles that get stuck in commercial jet engines and analyzing them using things like a scanning electron microscope and X-ray diffraction and X-ray fluorescence, if I could say the word properly, to understand where they come from on Earth, the dust comes from. So it's a completely different thing. But yeah, really interesting to use these new skill sets. And to be honest, I have no idea what John and the rest of them complain about when they say, oh, using these instruments is so difficult. You literally put your sample in it and go boop, bap, boop, beep, and then it gives you the information.
And that's why it's been broken for the past 2 weeks.
Yeah, well, because I've been on it going boop, bap, beep, boop. Yeah, you just pour water inside of the machine and then see what it does. You know?
Yeah.
So you've learned a lot during the postdoc. Wow, yeah.
But it's only for 6 months, though, isn't it?
Yes. Well, less than that. So it's only until January the 16th.
Okay, yeah.
So I'm going to have I'm definitely going to have a period where I don't have anything. But during that time, my plan is to just get something in industry somewhere for a bit. Because my fluency is in GIS work. So using like satellite images to analyze planets and things like that. So there's loads of other jobs out there. And I've applied for the ESA Research Fellowship and the Marie Curie Fellowship.
Yeah.
And they both start in September of next year. So.
Okay. Would that be for Manchester?
No, they're both abroad.
Oh, yes, that's right, yeah.
Marie Curie has to be somewhere in Europe.
Yes, that's right.
So I'm planning to do that in France with Dr. Nicholas Mangold.
Yeah.
Or the ESA one would be in the Netherlands with Dr. Elliot Carter, who we actually had on the podcast.
Indeed. And in fact, you would be then working alongside Fran too, I
yes,
suppose.
I would.
Campus.
Fran would be in a different department than me.
Right, but on the
yes,
same campus.
Yes.
Well, if you do get that one, I have to say, ESA do some fantastic umbrellas, so you'd have to bring back a bunch of those for us. They're very good. So you open them up, there's big golf-style ones, and on the inside, it's all blue, and it's got all the constellations and like stars and stuff, which is quite neat.
That is simultaneously the most and least relevant thing that you've said.
So I think we've sufficiently got off track.
Speaking of people doing work that they're kind of not been used to doing. Marissa,
Transition.
you have
There you
been
go.
away. You've been at Durham. Do you want to
Yes.
tell us a bit about that?
Yes, so back in August, I was away for 2 weeks at Durham University, actually looking at bubbles in non-Newtonian fluids. So yes, something completely different to what I normally do, which is modelling magma ascent on the moon, modelling different eruptions. So a few years ago, there were some interesting papers, more to do with fluid mechanics, looking at chains of bubbles in a fluid called it's HEC. It's some sort of cellulose-based liquid. And rather than bubbles traveling as discrete, separate pockets of air, as we'd normally see them in like fizzy drinks, they were traveling as like connected pipes. They sort of look like beads on a string. So the gas is traveling up through the liquid like that. And it's very strange to see. So as I was saying, it was just a few years ago that a small group of researchers were publishing on this, but more to do with, the properties, the rheology of the liquid. No one's really looked at this in the context of volcanoes.
So originally, did people just think, like you said, if you had a Coke bottle, you'd see this bubbles going through it? They thought volcanoes just acted the same as that then?
Yeah. So through volcanoes, volcanoes don't just release gas during eruptions, they can degas passively. So in between eruptions, just background amounts of gas are released. So it's still a bit of a mystery as to how volcanoes passively degas, so how they degas in between eruptions. And it was the idea of my supervisor here in Manchester and a researcher called Ed Llewellyn up in Durham to see if we could apply this bubble chain phenomena to the world of volcanoes. So I was there for 2 weeks setting up some experiments in these big Perspex tubes using this non-Newtonian fluid, which felt like really sticky PVA glue, but it was transparent. And bubbling gases through that and seeing at what different flow rates could I get these bubble chains to form. And therefore comparing that to the real world, thinking, oh, well, what flow rates does gas come through magma? Would we get these bubble chains? So yeah, it was very nice to have something different than computer modelling to do for the PhD, to have that as a nice side project.
It sounds like quite an important thing to have to take into account nowadays, though, if you're trying to model how volcanoes erupt, etc. Surely having to know how the gas actually travels through.
So one of the ideas is that there's magma overturn within the magma chamber, but again, a lot of people are saying, well, that would make pulsed releases of gas, whereas quite a lot of volcanoes have a steady background rate.
How good of an analog is this fluid? Because I know that when you set up an experiment like that, you have to consider how like whatever it is you're trying to model. So I'd say the main strength it has is the range of viscosities it displays, and also it's a viscoelastic material. So it's very strange. You'll have some in a pipette and you're dropping it out, and it'll just stretch for centimeters and centimeters. Whereas water, if you drop it out of a pipette, it'll just drop as individual droplets. So I'd say mostly in terms of the viscosity. They were very simple experiments, so they didn't have crystals in. I tried to do it without any bubbles in there, as in I let the liquid settle before I started running my experiments. But it is quite commonly used as an analog material. Okay, cool.
Can it tell you anything about what sort of gases are degassing?
No, so I was just using compressed air for it.
I guess what's quite interesting then, because in a lot of lavas that are solidified, you often see preserved gas bubbles called vesicles. Do you ever see any evidence in any lava flows of these sort of morphologies of bubbles and stringers and that kind of thing?
Not really. So you will get interconnected vesicles in lots of volcanic rocks, but you don't see nice clear structures of one bubble, a nice neck, and then another bubble
I guess
connected
they probably
in a
wouldn't
string
be
like
preserved
that.
on a lava that's on the surface. This
No,
is all
so
going on in like the conduit and in the magma
Yeah,
chamber.
so I think this would be more magma chamber depths rather than when it's been erupted.
I mean, how long you were there for? You were there for quite a few weeks, weren't you? I think.
I was there for 2 weeks, and I think we're going to continue the work. I'll be meeting with Ed Llewellyn from Durham next week to sort of see what we can do with the data, because as I said, it's not really been applied to the volcanological world, so it would be good to hopefully publish something.
And I think if you check out our Instagram account, there's a picture of those experiments.
Yes,
isn't there?
yeah.
So you actually did your undergrad at Durham, though, didn't you?
I did, yeah. So it was very nice to go back.
Nostalgic?
Yes, definitely. I actually stayed in my old college. So Durham has colleges. They're mostly just for accommodation. They're not anything to do with subject. But I stayed in my old college.
Did it give you deja vu?
A little bit, yeah.
Did it give you deja vu?
There's a collective groan in the audience there.
But yeah, it was very nice to be back. I met up with lots of old lecturers. Went to one of their volcanology meetings, which was nice to know everyone, get to know everyone there. It was very strange though, because it's the summer. It was the summer holidays then. They had lots of resits going on. So everyone there thought I was there to do resits. And I went, I graduated from here 2 years ago. But yeah, all the people at the accommodation, they were like, good luck, hope it goes well.
Oh, that's funny.
Of course, you were carrying your diploma around to
all the time. Yeah. I've got it attached to like a t-shirt.
And a PhD acceptance letter just so people knew.
Yeah.
Well, that's very exciting. Applying a novel technique to volcanic rocks.
Yeah, it was good. And I thought it would be good to get involved with terrestrial things as well as lunar things during my PhD, have the fingers in several pies.
Is it going to be complex enough or that you can incorporate into some of your models? But is it too?
I think it will be quite separate to my models, yeah.
That's great. Speaking of terrestrial stuff, because today is the day for segues. John, you've had some papers published this summer?
I had a paper published this summer. So it was really cool. It was quite an old data set, and I'd actually written the paper years ago, and I'd submitted it this time last year actually, and it's just taken this long to finally get published.
Wow.
Which was a bit frustrating.
Was there a lot of revisions?
No, it was just I don't know. The reviews that we got were pretty straightforward. It was just one of these things. People just take time to do the reviews and all that kind of stuff. But anyway, no, it was a good study. It was we were looking at so on my other hat, or with my terrestrial hat, I really like looking at mantle xenoliths, and so these are bits of rock that come from, the mantle, and specifically from areas called the subcontinental lithospheric mantle. And that long word basically just means the bits of mantle that are underneath continents. And so they tend to be melt residue. So you can imagine that, you melt a mantle to produce lava. And so continents are basically just large-scale melting events. And so you take a bunch of melt to form a continent, and then what's left is just the residue of this melting, and that's what we sample through these xenoliths. And most of these melting events, most of continent formation took place a really long time ago, sort of like 3 billion years, maybe a bit older, right at the very start of the Earth, really, I suppose. And so during this time, these areas of residue have just been isolated from most of the convecting mantle for this amount of time. So they can, in rare circumstances, preserve very pristine mantle that hasn't been touched really in 3 billion years. So these areas could have sometimes been modified by various fluids, as we call this metasomatism. And the fluids can be various compositions of like different gases and halogens and helium and all that kind of stuff. So what we wanted to do was sort of understand how these samples have been modified. Because these samples were from Siberia, and Siberia, around about the same time these xenoliths were extracted from the mantle and placed onto the surface, there was a huge outpouring of basaltic material associated with big mantle plumes. It's a big hot spot that generates loads of lavas. So you can imagine you've got a plume going through the mantle, and it's going to cause quite a lot of modification and potential chemical changes to these bits of mantle. And so we wanted to understand what effects do plume have on these areas of isolated mantle.
So just a simplistic question. How do these samples get to the surface?
Yeah, so they're very unusual volcanoes called kimberlites, and so they this is basically where most diamonds come from. Okay. All diamond mines, particularly from areas in South Africa, which you classically associate with diamond mines, come from these kimberlite volcanoes. And that's because they sample really, really deep. A lot of kimberlites sample down to 250 kilometers in the Earth's mantle.
Oh, wow.
And but they erupt really, really fast. So over the course, I can't remember exactly, but it's in the course of like minutes, basically, I think.
Yeah, I think it's like over a day, I think. And isn't that how it can preserve the conditions?
Exactly. Yeah. So you're basically ripping material from those depths, and you're basically then, because of how fast they erupt, they don't get modified by normal volcano type processes, and they get preserved as these xenoliths. And so Siberia is very lucky because it's got a bunch of these kimberlites that sample before the flood basalts, and a bunch of kimberlite pipes that sample after the flood basalt. So you can sort of compare the two to see what the mantle looks like. But it was very exciting. So we did helium isotope analyses and osmium isotope analyses, and long and the short of it, it does look as if there is some plume influence on some of these samples. But what's particularly exciting was that we did a plot of, on one axis, helium and the other axis, osmium isotopes. And what happens when you do a mixing relationship between those two? You get a hyperbolic array. And when I was doing my PhD, this is incredibly nerdy, one of the papers that I felt was really exciting in it, and the sort of geochemistry it wanted to do, was people can use mixing relationships of isotopes in mantle plumes to understand the composition of the mantle. Because if you can imagine a hyperbolic array, then you can use the asymptotes to constrain compositions. Because on one axis, because of the sort of the nature of a hyperbole, it will just keep going forever in one direction. That constrains the isotopic composition of one end member, and you can use different mixtures of hyperbole to look at the isotopic compositions of
and so did you do that in the paper?
That's what we did in this paper.
That's exciting. That's good.
So John, you've basically achieved your life goal.
Yeah, pretty much. Yeah, it's always good to have your goals quite low in life, so that they're realistic of achieving.
Living the dream.
So glad I strapped in for that part of the story. Off my seat with excitement.
Yeah, no, it's good.
Yeah.
We will link the paper in the description.
Yes. Yeah. So anyway, off the back of that bit of excitement, we're also very sorry to say that Ricci's not going to be around very much because of your postdoc. You're only going to be in a few days a week. So.
Well, essentially what's happened is I've outgrown you all.
Yeah.
Creatively, as well as
So I'm actually, if you guys want to tune into Ricci's own podcast, please do.
What's it going to be called?
It's going to be called Ricci's own podcast.
Okay.
The broadcast.
Well, in any case, we're very happy to say that the immensely talented Marissa Lowe.
Yes, I will be.
You will be
over the scepter.
Hopefully, taking
is there an
over.
actual scepter?
There is an actual scepter. You'll have to fill out numerous health and safety forms.
Okay.
But
Ricci, do you have any advice for me taking over from you for the podcast?
Just be amazing. I've got many messages from audience members just saying, "How do you do it? How do you keep it? How do you keep it so funny but interesting at the same time?" And so just go off those basically.
Okay, where do you get these messages? Because like we can see the account.
My email bombarded all the time.
Right. Okay.
Yeah.
Okay.
So we won't get into that, but yes, I'm passing over the reins to Marissa Lowe. I will be around in some of them, I'm sure.
Yeah,
some of the episodes.
as and when.
Yeah. So I understand if you all unsubscribe. That's fine. I get it. But yeah, thanks for listening for another episode.
No, seriously though, do like, comment, and subscribe.
Yes, and we will see you next week. Bye.
Bye.